Jai Hind everyone, my name is Amrita Bhatnagar. I am from CSE Department of AKGEC. Today I am going to explain about the transaction processing. This is the outline of my lecture. Firstly, we will understand about the transaction. What is transaction? Then we will see asset properties of the transactions. Then transaction state diagram or state transaction diagram I will explain. Then we will see what are schedules. And then in the last we will see types of schedules. So we will start with the definition of transaction. A transaction can be defined as a group of tasks. A single task is the minimum processing unit which cannot be divided further. Okay. So what the meaning of transaction? Transaction is a set of operation. For example, there is a two account. First account name is A and another account name is B. For example, A account have 500 rupees and B account have again 500 rupees. Now A wants to transfer that 100 rupees from the A to B. Now we want to transfer the 100 rupees from account A to account B. So now the 500 rupees will be deducted from the account A and 100 rupees will be added into the account B. Now this small work is known as a transaction because in this work there are many operations involved. Here 100 rupees will be deducted from the account A and 100 rupees will be added into the account B. So a set of operations are performed in a particular transaction and a work or a unit of work is completed in the case of transaction. So we can see this example. Again, you can see if there is a account A where we will open a account A, then old balance will be A dot balance, new balance will be, now when the transaction will perform, for example, 500 rupees is deducted in this case, so that we can remove 500 rupees from the old balance and we will get new balance here. Now we are deducted 500 rupees from the A account. Now new balance will be B balance. Fine. And again we will close account. So in this case we are transferring the 500 rupees from the A account to B account. Now what is the conditions for the B account? Now you can see here, open account B, old balance will be B dot balance, old balance plus 500. Now the 500 rupees will be added into the B account and new balance will be transferred from old balance to new balance. Now new balance is equal, B balance is equal to new balance, and again close the account. So in this case we have seen the example of transaction where we are transferring the some amount of money from the one account to the another account. Okay, so there are some set of operations performed in the transaction. Okay, so this, we can say transaction is a unit of work which performed by a set of operations. Now these transactions are based on the asset property. This asset property should be maintained. For example, a transaction is a very small unit of a program and it may contain several low level of tasks, which we have already discussed about it. A transaction in a database system must maintain atomicity, consistency, isolation and durability, which is also known as an asset property. Find asset properties in order to ensure accuracy, completeness and data integrity. So these four type of attributes should be maintained in the transaction at the time of transaction. So we will see what are asset properties now. First one is the atomicity. This property states that transaction must be treated as an atomic unit. Now the question is, what is the meaning of atomicity? Either of all its operations are executed or none. Either transaction will execute 0% or 100%. For example, consider a transaction to transfer the rupees 500 from the account A to B. In this transaction, if 50 rupees is deducted from account A, then it must be added to account B. So if we want to transfer rupees 50 from the account A to account B. So if the 50 rupees is deducted from the account A, then it should be added into account B. So transaction should be completely complete, finish, fine. It should not be partially completed. Or it should be a 0% completed. So atomicity means if the transaction should be executed 0% or 100%. There is no chance of 50% or 30% completion of the transaction. Fine. So we have to complete the transaction, or we have to complete only 0% transaction. Now, second property is consistency. In the case of transaction, there is a mandatory condition that after the transaction, database should be in the consistent state. It should not be inconsistent state. The database must remain in the constant state after any transaction. For example, if we want to transfer the 50 rupees from the A to B, what it means, we are transferring the 50 rupees from A to B, but database should be consistent. How we can find out data is consistent or not? We can find out by the help of A plus B. If the value of A plus B before the transaction is 500, then after the transaction the value of A plus B will be 500. Fine. So it means database is a consistent. We cannot have the value A plus B is equal to 400 or 300. It should be same before the transaction or after the transaction. What it means? It means the database is in the consistency state or consistent state. This is the second property of asset property. Now next is the isolation. What it means? In a database system where more than one transactions are being executed simultaneously and in parallel, the property of isolation states that all the transaction will be carried out and executed as if it is in the only transaction in the system. No transaction will affect the existence of any other transaction. Okay, so we have to maintain here concurrency also, because more than one transaction can execute simultaneously, but there should not be any interference of the transaction between the different transactions. Okay, for example, if the two transaction T1 and T2 are executing simultaneously, for example, then they should not interfere to each other's result or in each other's processing. So this is known as a isolation property. Now durability. Next is the durability. After a transaction completes successfully, the changes it has made to the database persist permanent, even if there are system failures. Once our transaction completed up to the last step, its results must be stored permanently. Fine. It should not be removed if systems fail. Okay. So what it means, durability means if we are storing a data into the database or storing some transaction or operations in the database, it should be permanent. It should be completed. It should not remove from the database. For example, if we are transferring the data, some amount of money from A account to B account, then it should be deducted permanently from the account A and it should be added into the B account permanently. It should not remove after the failing of the system. The database should be permanently saved. Okay. This is known as a durability. These are the four properties of the asset property. A for atomicity, C for consistency, I for isolation and D for durability. These are the four main properties of the database or transactions, and it should be maintained at the time of transaction. Now the next is the transaction state diagram. Here we will see different states of the transaction or these states through which the transaction goes during its lifetime. There are states which tell about the current state of the transaction. These states govern the rules which decide on which state of the transaction whether it will commit or abort. So we will see the diagram. We will understand this transaction state diagram with the help of a diagram. You can see these are the main states of the transaction. So firstly, we will see there is a first state which is known as an active state. Active state is that state of the transaction where transaction is executing. Okay, when the transaction is executing, it means it is in the active state. Fine. Now, next one is the partially committed. Partially committed means when we executed all the operations of a particular transaction, but it is not committed yet. Commit is a statement. By the help of this commit statement, we can save the changes permanently into the database. So when the transaction is a partially committed, what it means? It means it have already executed all the operation of the transaction, but it is not committed yet. When the transaction is executed commit statement, then this is known as a committed state. After the complete operations of the execution of the complete operation of the transaction, we have on the partial committed state, and when the commit is also performed, then we go to the transaction will go to the committed state. Fine. So when the transaction is successfully committed, then end will here come. Okay. So this is the first step where the first condition where the transaction is successfully committed, and there can be another possibility that transaction is not successfully committed. Then there is a possibility of failure of a transaction. There can be many reasons for failure of the transactions, but there is a possibility to fail. It can be a power failure, or it can be any reason for failing the transaction. So there is another condition. If the transaction is not successfully executed all the operations of the transaction, then it will come into the failed state. This is known as a failed state. And when the transaction is failed, then there should be maintain atomicity in this case. To maintain the atomicity in the case, we cannot have a partially committed or we can say partially completion of the, we cannot accept partially completion of the transaction. So we have to come on the next state, which is known as a aborted state. Aborted state means in the case of aborted state, we have to roll back the transaction. We cannot accept the 10%, 20% or 30% completed transactions. If the transaction failed at the time of 50% completion of the transaction, then we have to roll back the transaction. And this rollback condition, when the transaction roll back, then this state is known as an aborted state. Fine. So we cannot accept 10 or 20 or 30% completion of a transaction, because we have to maintain atomicity in this case. So after the aborted the transaction, again the next condition will come, which is known as a end. But there is a main concern here that partially committed transaction also can be failed, because there can be some reason of integrity constraint. If the integrity constraint not allowed to transaction perform, then there can be a partially committed transaction can be failed again. And if the transaction is failed, then again it have to come to the aborted state, and again into the and again it have to roll back. So these are the all states of the transactions. Now again we will see the explanation of each and every state of the transaction. Active, in this state transaction is being executed. This is the initial state of every transaction. Partially committed, when the transaction executes its final operation, it is said to be partially committed state. Then next one is the failed. A transaction is said to be failed state if any of the checks made by the database recovery systems fails. A failed transaction can no longer proceed further. Next is the aborted. If any of the checks fails and the transaction has reached a failed state, then the recovery manager rolls back all its write operations on the database to bring the database back to its original state where it was prior to execution of the transactions. Transactions in these states are called aborted. the database recovery module can select one of the two operation. Transaction aborts. Restart the transaction or kill the transaction. So aborted state is that state where we will mostly roll back the transaction. Committed state. If the transaction executes all its operations successfully, then it is known as a committed state. All its effects are now permanently established on the database system. In the committed state means now transaction is successfully completed. Fine, and all the changes occur by the transaction is saved permanently into the database. Now the next topic is what is schedule? Schedule. Now we should understand there are some different type of schedules. A schedule is a process of grouping the transaction into one and executing them in a predefined order. A schedule is a chronological or sequential order in which instructions are executed in a system. A schedule is required to database because when we have some transaction execute in parallel, they may affect the result of other transactions. Fine. Means if one transaction is updating the values which the other transaction is accessing, then the order of which two transactions will change the result of the another transaction. Because now we have concurrency in the system also. Concurrency means we have more than one transaction. If only one transaction is executing in a system, then there is no problem. But when we have more than one transactions, then we have to create some schedule for the transaction so that the transaction will not affect to each other at the time of execution. Right? It should not change the result of another transaction because they can be work on the same data or same time. So we have to make some schedule, or we can say these are the group of transactions. Fine. So we will understand, we will see the example of schedules. What are schedules? Now you can see this is a one schedule of transaction. There are two transactions, T1 and T2. So you can see here in the first transaction, firstly we have read account A, then we will remove n amount of money from the A account, write A, read B, add the n amount of money to the B account and again write B. So this is the whole T1 transaction. When the T1 transaction is completed, then the another transaction T2 is begins. So this is known as a schedule where we have only two transactions, but in the schedule we have more than one transaction, more than two transactions also. Okay, so this is known as a schedule because firstly T1 is started and then T1 is completed, and after that T2 will start and T2 will complete the transaction. This is a serial transaction. Now we will see what is the meaning of serial and non-serial, because transaction can be of different types. You can see the types of transactions schedules here. We have three types of schedules. First is serial schedule, second is non-serial schedule, and third one is serializable schedule. So this is firstly we have seen the example. This is the serial schedule. You can see here this is the serial schedule. Now we will understand what is the meaning of serial schedule. The serial schedule is a type of schedule where one transaction is executed completely before starting of another transaction. In the serial schedule, when the first transaction completes its cycle, then the next transaction is executed. So, okay, suppose there are two transactions T1 and T2 and which have some operation. It has no interleaving operation. What it means, we will see in the example. You can see here we have two transactions here, T1 and T2, but no operation. Firstly T2 is starting, and when T2 will complete its all operation, then only T1 will start here. So this is known as a serial transaction, serial schedule. So there are no interleaving instructions here, the operations here. So it will not interfere the processing of each other, because this is the serial transactions. Okay, so this is the example of serial transfer schedule where there will be no interleaving operations. Fine. Now there can be non-serial schedules also there. If interleaving of operation is allowed, if we allowed interleaving operation means if the transaction T1 is not completed but the T2 transaction is also started meanwhile, then it is known as a non-serial schedule. Then there is a non-serial schedule. It contains many possible orders in which the system can execute the individual operation of the transaction. Now you can see the example of the non-serial schedules. You can see here, this is a transaction T1 where T1 will read A, then it will remove an amount of money from the A account. But this transaction is not completed. When the T2 will start, T2 again read A and add the M amount in the same data A. Fine. So this is known as an interleaving instruction, because these two transactions are working on the same data. One is removing the N amount of money from the transaction from the account A, and another adding the M amount of money into the account A. So now transaction T1 write A and read B again. Then after these two instructions, again T2 will execute write A. Then B is equal to B plus N, and then write B. So you can see here these are the interleaving instruction or operation there. This is known as a non-serial schedule. Fine. So these two transactions should not interfere each other's process or each other's result. It should not change. Fine. This is known as a serializability. We have to check all the non-serial schedules that it should be serializable schedule. Now the question is, what is the meaning of serializable schedule? Or we can say that if we change the sequence of the instruction, then we have to get a serial schedule from a non-serial schedule. Then it will known as a serializable schedule. Now we will see the definition of the serializable schedule. A schedule is serializable if it is equivalent to serial schedule, which I have already told you. We have to convert we can convert a non-serial schedule into the serial schedule by the help of non-interfering instructions. In serial schedule, only one transaction is allowed to execute at a time, and no concurrency is allowed. Whereas in serializable schedule, multiple transactions can execute simultaneously and concurrency is allowed. Fine. In the case of serial schedule, we cannot execute more than one transaction simultaneously. But in the case of non-serial schedules, we can allow concurrency. What it means? We can execute more than one transaction at a time. Fine. But we have to check the serializability of a non-serial schedule. Non-serializability means it should be equivalent to a serial schedule. And to check out the serializability, we have to check two types of serializability: conflict serializability and view serializability. Okay. So now we have completed the basic concepts of transaction. I hope you have understood all the concept very easily. Thank you.